This is check-in 2 for group What the Heck 15.
Our work this week consisted of gathering more data, processing, filtering, and segmentation, and extracting of compressions. Our primary focus is to simulate and accurately measure compression depth.
As a metric for tracking chest compressions, we must have a standardized depth and recoil that we are aiming for. The target per American Heart Association guidelines is 2 inches. In order to meet this goal, we were thinking of practical ways to be able to standardize the data we will collect. Ideally, we would be able to gather data directly from an electronic mannequin that indicates whether or not chest compressions are being done correctly.
We have reached out to the Regional American Heart Association, the Red Cross, and a local hospital, but have not received a response as of yet. In the meantime, we have designed a device that can simulate compression at a depth of at least 2 inches, 2.2 inches specifically.
A preliminary design has been drafted, which can be seen in the bottom right corner. The challenges of creating such a device have included the construction. When attempting to 3D print a design, multiple prints have failed because of the size of the device. The device has to be large and durable to withstand the act of compressing, which has led to long print times. Currently, we have been fine-tuning the 3D printer to accommodate this design.
The device will use springs to push the upper part vertically upwards as shown in Figure 1. In Figure 2, the user can press down on the extended block at the top to a max of 2.2 inches. That means we will be able to compress regularly at the target depth.
In order to obtain a consistent process for detecting compressions, we implemented the activity recognition chain. Our first attempt was gathering compressions at a variable depth, but at consistent rates using a metronome to track rhythm. We started with 100 beats per minute and 120 beats per minute, since this is our target range.
Raw accelerometer data was gathered then pre-processed to magnitude data. The magnitude data was filtered with the moving average where n equals 10. Feature extraction and classification of compressions was done by tracking peak magnitudes. Via this method, compressions were accurately counted at 30 compressions for each set of data. The next step is verifying that beats per minute can be accurately and consistently measured from our data. Here we can see an accurate tracking of compressions.
Now that we have created a plan to record data on various depths of compression, we will finish producing the device in the next coming week and gather data at different depths and recoil lengths in order to segment proper and improper compressions.